We're on live, everybody.
Okay, so this chapter we're going to talk about matrices. A matrix is just a rectangular arrangement of numbers by rows and columns. So here's an example. They give you this matrix here. All of the columns represent different restaurants. Column 1 is Gina's, column 2 is Vinny's, column 3 is Tony's, column 4 is Sal's.
Right.
Each row represents what they sell. So row 1 is the price for pizzas, row 2 is a price for drinks, row 3 is a price for salads.
Gina's Texan.
They've taken it, and all they've done is taken the numbers and drawn these fancy brackets around them, and that's called a matrix.
Oh,
that's it. That's it. That's a matrix. It's just an arrangement of numbers in rows and columns. Okay?
In brackets.
Oh, we are going to add, subtract, multiply.
Divide.
No, we don't divide. Okay, so each number within your matrix is called an element or entry of the matrix. Individual elements are identified by row number and column number. Okay, so column 1, column 2, 3, 4.
Yeah, 1, 2, 3.
Row 1, row 2, row 3. Okay, so columns. Columns go up and down,
Side to side.
and rows go left to right. Columns are always listed first. It's always listed column by row. Or I'm sorry, no, row by column. Row by column. So your value here, 10.65. This value right here is in row 1, column 4. So we'd identify it as A sub 1, 4. Row 1, column 4. So A sub 2, 1. That means row 2, column 1. What number is there? 1.15. Okay. Row 2, column 1. Where do those two intersect? Okay. What about A sub 1, 2? 10, 10. Row 1, column 2.
Oh, so the row is first.
Row is first, column is second. A sub 3, 4. 3.85. Okay. If you need to put beside this, this is row 2, column 1. Row 1, column 2. Row 3, column 4.
Got it.
Now they want us to work backwards. They're going to give us a number. They want you to tell them where is that in the matrix. So, good. 12.16 is right here. So that is row 1, column 1, which is A sub 1, 1.
Wait a minute. Oh, they want you to do.
What if it's the A1?
Row 1,
right, but I
column
list
1.
the RTC one. Or you listed it on the side?
What here?
Yeah,
Row 2, column 1.
I thought it was column 2, row 1.
This one's row 1, column 2.
Don't columns go first?
No, rows go first.
Rows go first?
The element in row 1.
R2, C4. Well, row 2, column 4.
Row 2, column 4.
And it'd be A24.
Good. Row 2, column 4, which is A sub 2, 4.
Row 3.
A sub 3, 2. Okay, this is in row 3, column 2, which is A sub 3, 2. Okay, so you have to be able to identify where these are. Questions?
It's pretty easy.
Adding and subtracting is super easy, and we can do it without the calculators, but I will also show you how to do it in the calculator. Multiplication is very difficult, so I'm going to do nothing but calculator. When I grew up, this is how they taught us systems of equations.
Dang.
It's so much easier than the way they teach you now. No lie. I'd rather go back to this. Okay, so here's matrix B. What is the value of B sub 3, 2? That is a 3. Okay, this is row 3, column 2, which is a 3.
Well,
1, 3.
12.
12. The location of 4.
Row 2, column 2.
B 2, 2.
Oh, I put the row in the column.
B22.
B22, beard.
Okay.
B22.
It's called B because your matrix is called B. Okay. Identify the location of the number 15.
4, 3.
4, 3. Good. B sub 4, 3. The last part, given a matrix n, what location are you looking for the given element? If I have n sub 5, 3, that's row 5, column 6.
Oh, 2, 1.
Row 2, column 1.
7, 4.
Row 7, column 4.
4, 9.
And row 4, column 9.
That's my GPS.
What, 49?
Backwards.
94.
It is 9, 4, 9, 4, 4.
You're like super genius and should go off to college
I
already?
think I should drop
You should
out.
have been at college.
Right, like, what are you doing here?
I just wanted to stay in my right grade.
Okay, the dimension of a matrix is determined by the number of rows and columns. Just like your elements, we label our matrices by how many rows and how many columns. So, what is the dimension of matrix A? How many rows does matrix A have? 3. And how many columns? 4. So matrix A is a 3 by 4 matrix. Okay. It's a 3 by 4 matrix. I threw the matrices up there from the previous page, so you didn't have to keep flipping back. Okay. Matrix B.
It's a 4 by 3.
It's a 4 by 3 matrix.
I know you see me. I told you what my GPA was.
Your dimensions are also going to tell you how many elements are in there. So how many numbers are in there? If I have a 3 by 4 matrix, I have 12.
Wait a minute, I need to understand what you have.
Okay. If I have 3 by 4, how many numbers are in here?
Oh, 12.
Just like area.
Oh,
Okay. If I have a 4 by 3,
12.
I still have 12. Okay. What if I have a 2 by 8 matrix? 5 by 6,
30.
3,
18. Let's get it by 7,
7,
9,
9,
8.
8.
That GPA coming out of me, boy.
Okay. Question.
No, this is easy peasy. Let me
Easy
squeeze.
peasy lemon squeezy. Okay, we have 2 types of specialty matrix. One is called a column matrix. It can have as many rows as you want, has 1 column.
Dang.
Okay. So if you create a matrix using Sal's menu items from that previous matrix on the front page, it results in a 3 by 1 column matrix. Write a column matrix for Vinny's. So flip back to your matrix on the front page.
10, 10.
Okay. So Vinny's numbers is $10.10 for pizza,
$1.09.
$1.09 for drinks,
369.
and $3.69. So this is a column matrix for Vinny's. It has all of the numbers for Vinny's restaurant.
I'm gonna go to Denny's today.
Salad prices.
Oh, where?
Salad sounds really good right now.
Huh?
Salad sounds really good right now.
Don't sell.
Type of salad.
That sounds really good.
Go back to work.
Row matrix is a matrix with only one row. So if you create a matrix of only the pizza prices of the 4 restaurants, it would look like this. Okay? Gina's is 1216, Vinny's is 1010, Tony's is 1086, and Sal's is 1065. Create a row matrix for salad prices.
4.05,
4.05,
3.69,
3.69,
3.89,
3.89,
3.85.
and 3.85.
Ooh, I'm gonna go with that.
$4 for a salad.
No, 12 and still
I
not
don't know,
16
maybe
cents
it's got
for
some like
pizza.
grilled steak, grilled chicken, shrimp on it. I don't know.
You better have everything. They taxing 12, 16 for pizza.
Drinks be like $3.
They tax 10, 1086.
Well, then you go right ahead and pay the 1086. Okay. So we're going to create matrices from what they give us. So a garment company receives orders from 3 clothing shops. Shop 1 orders 25 jackets, 75 shirts, and 75 pairs of pants.
Dang.
Shop 2 orders 30 jackets, 55 pairs of pants, and 45 shirts. Shop 3 orders 40 shirts, 20 jackets, and 35 pairs of pants. Display this information in a matrix with columns as jackets, shirts, and pants. It's very important that you pay attention to how they want it. We want columns as jackets, shirts, and pants.
Right.
So column 1 should be jackets, column 2 should be shirts, and column 3 should be pants.
Okay, the first one for J is 25.
Okay, so if jacket, shirts, and pants are across the top, what's going to be my rows?
Shop 1 and shop 2.
Shop 1, shop 2, and shop 3. Okay, what number goes here at 1, 1? Shop 1, jacket.
25.
25. Would you want to do the row or you want to do the column?
Row.
Let's do the row, okay? Shop 1, shirts.
75.
75. Shop 1, pants.
75.
75. Okay, now we're going to jump down and do shop 2. Shop 2, jackets.
30.
30. Shop 2, pants.
30. Wait, no.
55 goes over here. Notice they put this out of order. They went jackets, pants. Well, yeah, jackets, pants, shirts. Okay, so pay attention to where you're putting your numbers. So shirts go in the middle,
45.
45 in the middle.
Yes.
Okay, and the last column or the last row from left to right: jackets, 20, shirts,
40.
and pants.
35.
Perfect.
I know.
Perfect, fantastic, and wonderful.
No, ma'am. This is easy.
Easy peasy lemon squeezy.
I like lemons.
Okay, for breakfast, Yoko had cereal, banana, a cup of milk, and a slice of toast. She records the following nutritional information in her food journal. Okay, so we're talking about calories, carbs, fat, and cholesterol. Okay, it says the rows represent the foods. So my rows are my foods. How do you want to order them?
Let's order pizza first.
I'm not talking about pizza.
Oh,
Cereal,
Banana,
banana,
milk,
milk,
toast.
toast. Okay. My columns are going to be calories, carbs, fat, and cholesterol. So calories, carbs, fat, and cholesterol.
Okay.
So this is a what by what matrix?
4x4.
4 by 4. Perfect.
We have 16 entries.
That means 16 elements or entries. Okay, good. So cereal, calories. Calories,
165.
165. Carbs,
33 grams.
fat,
3 grams.
and cholesterol.
0.
0. There is none. 0 is not bad for you, I guess. Carbs, yeah. I don't do carbs very well. Banana, calories,
120.
120. Carbs,
26.
fat,
0.
and no cholesterol.
Eight.
Bananas are super healthy. Okay. Milk, calories,
120.
carbs,
11 grams.
okay, fat,
5.
and cholesterol.
15.
And finally, my last row is for toast, 125.
14. 6 and 18.
Perfect. One slice of toast. Believe it or not.
That's why I don't eat toast. I eat cheese toast.
White toast is awful for you.
Huh?
It's mostly white toast.
What's this? Well,
Whole wheat.
Ooh,
Whole wheat's not bad. Multigrain's better. Okay. This is supposed to be a matrix operations review. Okay. You've never done matrices, so this is not going to be a review. This is going to just kind of be a lesson. Adding and subtracting is super easy, and multiplying by a scalar is super easy, and that's what we're going to cover today. Tomorrow we're going to get into the nitty gritty with actually multiplying like a 3x4 and a 4x3. Okay. So this is what we call a square matrix. Why do you think we call these square matrices?
because they have the same number of sides.
Good. Same number of sides. This is a 3x3. This is a 4x4. So when you have the same number of rows and same number of columns, this is called a square. Okay. These are symmetric. Okay. Across what they call a main diagonal. Your main diagonal goes from the top left corner to the bottom right corner. Okay. So top left to the bottom right. This is your main diagonal. Your matrix is symmetric if your numbers across from that diagonal match. All of them must match. So what I mean by that, 2, and across from that is 2. 7, and across from that is 7. So far, so good. -5 and +5. That's a no-no. So K is not symmetric. Okay. All of those numbers must match. Go ahead and check matrix L. I mean, you can go right ahead and draw in your main diagonal. And look at all of your numbers opposite the diagonal. Okay. Where he says it's symmetric.
Yes.
You've got 7 and 7, -1, -1,
4, 4.
And 8,
8, 8, and 4, 4, 4, 4 again, -2, -2. All of them work. Okay. The elements of the main diagonal for matrix K are K sub 1, 1 is 0, K sub 2, 2 is -1, K sub 3, 3 is 4. What do you notice about all of these?
They all have,
If they're in the main diagonal, they're all in the same
Same spot?
spot, kind of.
They go in
Yeah.
order. 1, 2,
Okay.
3.
1, 1.
3.
Okay. They will all be double digit. Identify the elements and the values in the main diagonal of matrix L. So we're going to have L sub 1, 1. What's there? 3. L, the next one is going to be 2, 2.
-5.
-5.
6.
3, 3 is 6. and 4, 4
Zero. Fucking nine.
is 0.
Zero. Fucking nine.
Questions?
Can you go back over? Please.
Got it? Okay. Addition and subtraction. If you add or subtract, only if they have the same dimensions. Okay, so a 3 by 3 or a 3 by 3 can only be added to a 3 by 3. 4 by 2 can only be added to a 4 by 2. Okay, so tell me here. A, can I have a solution for that?
Yes.
Yes. Okay, this is a what by what? 2 by 2 and a 2 by 2. So yes, there is a solution. B,
You got a 2 by 3 and a 3 by 2.
you got a 2 by 3 and a 3 by 2. Is there a solution there?
Yes.
Yeah.
Are they the same dimensions?
No.
No.
No. It's opposite dimensions.
Oh.
They have to be exactly the same.
Okay.
What about C?
You got
No.
No. This is a
2 by 3.
2 by 3
2 by 2.
and a 2 by 2. And finally, the last one.
No. Wait.
Yes.
Yes. Never mind.
Yes. Even though this one looks skinnier, the only reason this one looks fatter is because your negatives spread it out a little bit more. This is still a 3 by 2. Okay. So do not let that confuse you. On your test on Friday, you're going to see something like this, but it's going to be mixed in with multiplication. So if I have a 3 by 2 and a 3 by 2, can I add them?
Yes.
Yes.
Yes. Guess what? If it starts a 3 by 2, it ends a 3 by 2. Okay, your dimensions do not change with adding and subtracting.
So
Multiplication, they will.
it's basically a yes, like if they're matching.
Okay, if I have 4 by 5 and a 5 by 4, can I subtract?
No.
No. Which means I don't need a dimension because you can't do it. What if I have 6 by 6 and a 6 by 6?
Yes.
Yes.
Yes. And my final dimension would be 6 by 6. 4 by 4 and a 2 by 8.
No.
Nope. Okay. Question. Zephaniah. Come on, Frank.
This one, dude. Come
Okay.
on.
So here's how we add. The number in the top left adds together with the number in the top left to give you the answer that goes in the top left.
You add the corresponding numbers.
You add the corresponding numbers. So 11 pairs with 9 to give you this answer.
21.
Plus 10 to give you this answer. So on and so forth. It works the same with subtraction. So wherever it lands on the matrix, you pair it wherever it lands on the other matrix and give me an answer. Okay. The last thing is scalar multiplication. So in other words, all you're going to have is this fancy number on the outside of the matrix. So another example would be something like this. Okay, it's just a number hanging out on the outside, just like you had like 3 times x, and then I told you x was 2. So you multiply everything by this number on the outside. So you would take 4 times 1, which is 4. 4 times 2, 8. 4 times -3, -12. 4 times 4, 16. 4 times 0, and 4 times 5, And that's your answer.
Oh.
That's easy.
Fantastic. I like to hear that. Nice and easy and sweet.
Understand this more than we did last time.
Yay! That's exciting. Okay, the last thing I want to show you before you go to lunch is how to enter these into the calculator. Okay. Second plus 712. My math 2 class comes in and says, what in the heck do you do with these calculators? Because we've got stuff everywhere in this class. They get so confused.
So weird.
Okay. So to create the matrix, you hit second matrix. Matrix is right above this x to the negative 1. So second matrix. That brings up this. Okay? These are all of your matrices. Matrix A, B, C, D, E, F, G. There is nothing in them. If there was something in them, it would say like 2 by 1. Okay.
How'd you get the matrix again?
Second.
Second next one.
And it's x to the negative 1 there.
Oh, okay.
Okay. You're going to scroll over to edit. Okay. And you want to edit A. So you can either hit 1 or hit enter because A is highlighted. Okay. So look at matrix A under where it says matrix operation practice. A is a what by what matrix? 2 by 3. So you have to hit in 2, enter, 3, enter. And it brings up a bunch of zeros. You're going to need to now enter in the numbers. Okay? It goes from left to right. So -2, enter. It'll move over to the middle. 6, enter. 7, enter. 8, enter. 9, enter. 3, enter. You just entered in matrix A. Okay. Go back out, hit second, go back to your matrix. We need to put in matrix B. So you're going to scroll over to edit. This time, go down to matrix B and hit enter. B is also a 2 by 3. Oh, not 23. Whoa. 2. Delete. Okay. I got 3. -4. 2. 5. 7. And -1. Okay. And finally, enter in matrix C. What's my board getting on the line already?
We don't want to calibrate that. It's gonna get you.
Yeah. It's already on my nerves.
Hey, you gotta make more about 2 or 3 times a day.
2 or 3 times a period. Drives me nuts.
Yeah, 20 clicks.
Okay, edit. Choice 3. And we said that's a 3 by 2. Okay, we got 2. 8.5. 3. -4. 8.5. And 5. Okay, so if we go back to here,
Just like randomize.
really?
Yes.
Okay. Here are all the matrices we just entered in. Here's what they want us to do with them. So they want to find A minus B. You can easily, -2, -3, so on and so forth. But on your calculator, if you go to quit, okay, so second mode, they want A minus B. So go to second matrix. You want to choose matrix A that you have entered in. And then you want to subtract. And then you want to go and choose matrix B that you have entered in. And hit enter.
Oh, that's fancy.
There's your matrix. Okay? You can do it all by hand, or you can do it this way. When we multiply tomorrow, you are going to want to do it this way.
All right, that was easy.
Right.
So I guess this all until lunch. Yep.
What, you feeling lazy today?
Yeah, it's my, I mean, it's
We're
Monday.
gonna go over B where it says
Right.
5, 4.
Okay, so this was 10. This was 5.
13.
That was
I mean, 3, 2.
4.
2, and 4. 5. How about you finish these real fast and then we'll stop. Let's do B by hand. Find 4C. So what does this 4 on the outside of C tell us to do?
Multiply.
Multiply. We're multiplying everything in here by 4. So 4 times 2 is 8. 4 times 3, I'm going to go straight down that column.
12.
12. 4 times 1.5.
6.
6.
6, baby. 6, baby.
4 times 8.5.
34.
34.
Dang,
Well.
you're good at this, huh?
He already plugged it into his calculator. 4 times -4. -16, and 4 times 5.
20.
20. Okay. What about C?
We can go in the calculator.
Plug it into your calculator and see what happens.
No solution.
No solution.
What does it say?
He said no solution.
Not saying a solution. Not what it says.
It's an error.
It says error. What does it
Error.
say after error? Mismatched dimensions. Okay? That means that it can't be done. It's not possible. This is a 3 by 2. This is a 2 by 3. So this one is not possible.
Not hot. Not hot.
Okay? And finally, D, you can plug this straight into your calculator. 2. You've got that scalar on the outside. Second matrix, A. And we're adding that to matrix B. And there's your answer. Calculator does order of operations for you. So it multiplied matrix A by 2 first, and then it added matrix B. So can somebody read me that so I can put it in here?
-1, 16, 21, 25, 5.
Perfect. Any questions so far?
We can chill. I can take me a quick 2-minute nap.
Quick 2-minute nap.
The hell?